right, so now let's take a look at, let's see, you said problem 14. Let's go over that one first. Okay, so correct me if I'm wrong, but this should be, did you say 14? Yeah, you did. You have p squared plus p plus 8 all over p squared, so this should be 14. P squared minus 7p plus 6, and this is 2 over p minus 1 is equal to 2/3. Is that the problem?
Yes, sir.
Okay, so remember what you have to do, and I think they're hard for me to explain, so therefore it must be hard for some people to understand what is it that I'm supposed to do, but what you're supposed to do with these, right, is that, let me actually maximize this. I just realized that's tiny. All right. So what you're supposed to do with that is you're supposed to factor this first. Let's see, factors of 6. They add up to 7. There it is, right?
Yep.
Now, the reason I do that is because what I'm looking for is I'm looking for the lowest common denominator, okay? So the way to think about this, kind of like the last time me and you talked, the way to think about this is to think, let's think about, if I were to try to, forget about the 2/3 for a second, if I were to try to find a common denominator here, you would probably agree with me that I would multiply this side right here times p minus 6 top and bottom here, right?
Yep.
So far my common denominator should be p minus 6, p minus 1. Well, then I also have this 3, right? And there's nothing I can do in terms of just multiplying one thing. So what I would do here, just kind of covering that up because that's irrelevant at this point, to have a common denominator for those two, you would have to multiply this side right here times p minus 6 and p minus 1. And I would have to multiply this side times 3. Does that make sense?
Yeah.
So I'm going to multiply all of this times my common denominator, which is 3, p minus 6, p minus 1, like that. Okay. Now, from the stuff we talked about in the previous video, I mean, I'll show you again. What happens is that I'm distributing. So this is, you might want to hold off on writing this for a second, just to see if you even want to write it. But essentially, I'm going to multiply this times 3, p minus 6, p minus 1. So I'm just basically distributing, and I'm doing that in case that anybody that happens to watch this video sees, like, it's wondering how or what I'm doing. All right, so I'm going to multiply this times the common denominator, but I wouldn't advise you for you to write it right now, unless you really want to. And finally, you have equals to 2/3, and I'm going to multiply that times 3, p minus 6, p minus 1. Okay, now, the reason that we do that is because notice that on this one, that's going to cancel with this, okay? So what I have left is 3 times p squared plus p plus 8. All right, on this side, the p's minus 1 cancel, and I end up with 2 times 3, which is 6. So this is 6, p minus 6. Okay, and then finally on this side, notice that the 3's would cancel. And I would end up with equals to 2 times p minus 6, p minus 1, which we know if you FOIL that, you get back to what you had here originally, p squared minus 7p plus 6. Okay, so I'm going to distribute. And I would have to FOIL this, okay? So I have to FOIL this. I have to FOIL this and then multiply whatever the foiling part is times 2. Now, I know that when I FOIL, I get this, right? So I'm going to skip one teeny tiny step here, and I'm just going to multiply this times 2, and I'm going to put that right here because that's what that is anyway, right? So we have 2p squared minus 14p plus 12. Okay. So then now after that, right, only because you can add like terms on the left side if you want to before you do anything, but essentially I want to set this equal to 0, right? Because remember, anytime you have a square function, which in this case I do have a p squared there and a p squared there, I want to set that equal to 0 first before I do anything else, before I try to factor. But let's go ahead and let's see if there's any like terms on this left side first. Let's see, we have a 9p. Let's see, and 24 minus 36 is going to be negative 12. And that's equal to 2p squared minus 14p plus 12, like that. All right. And then now I'm going to do what I said I was going to do, which means I'm going to subtract everything to one side. That's going to be 0 on the right side. That's going to be 23p minus 24 is equal to 0. All right, so we do all of that crap just to get to that point, and at that point, I'm hoping that I have something that's factorable. Right, if it's not factorable, you have to use the quadratic formula, but there's no need for that, right? If you happen to use the quadratic formula, that probably means you did something wrong, just in this specific problem, just because we don't have anything that requires that. So let's see, plus 24 minus 1. So my answer should be negative 24 and then positive 1. Okay, let me look at the answers that I sent you earlier. Because I'm not even looking at my key right now, so this is dangerous. Let's see. Okay, so notice that I only have p is equal to negative 24, right? That's the answer if you look at the key that I sent you. Now, there's a reason why, right? If I go back all the way to this original part, the original problem, right? Remember, I have to have this. I would set each denominator cannot be equal to 0. Now, this one's kind of a death thing. That's not going to happen. 3 is not going to be equal to 0. Now, p, if I add 1 to each side, then p cannot be equal to 1. And this one says that p cannot be equal to 6, and p can also not be equal to 1. So notice that p cannot be equal to 1 is right here. Okay? Which means that this is why you cannot have this as an answer. So that's the only answer that you have. Does that make sense?
Yeah, kind of.
Okay. Is there anywhere in the yeah, kind of doesn't make sense? Like, did this process make sense?
I mean, I think my main struggle is just trying to find what to
Lowest.
like trying to find a common denominator.
Right,
the
lowest common denominator.
Common.
So basically, here's the thing, Carter. Once you actually factor everything out like this, then like my common denominator, since I already have, if this were different, for example, if this was different than either one of these, then my common denominator would be this times both of these. Does that make sense? So basically the common denominator, here's how you know you found the right common denominator. When I multiply times the common denominator, the denominators need to be canceled. You see how the denominators cancel every time? And if that didn't happen, then you did something wrong. All right, so let's look at 15. So I'm gonna minimize this for a second. Let me look at 15 real fast. I think it's the same type of problem, and at the very least, we can talk about what the common denominator would be for that one, right? So 15. So this is kind of a long problem, not necessarily typical of what we are doing on this. So 15. is 1/3 minus so step one is to factor the denominators. There's nothing I can factor here, so I'm gonna leave that alone. And yeah, I did say that right. The denominators. The numerators, leave them alone. You don't have to do anything with that. On this one, I only have a common factor of 3. So this is 4v plus 3. Okay. So let me maximize my window here. So here's the old Carter, all right? Notice that my common denominator is going, like, you basically can take it one at a time if you like. By that, I mean, I don't really need a common denominator here, do I? And this is already, it's only one fraction, so we don't need a common denominator here. But on this side, I do need a common denominator, right? Yeah. So I would have to multiply this right here times 4v plus 3 top and bottom here, and this one by that top and bottom. 3. Does that make sense? So right now, my common denominator for my lowest common denominator is going to be 3 parentheses 4v plus 3. Okay? But it happens to be that when I go to this side, that denominator is already here. So I don't have to do anything here. Does that make sense? Now, let me show you opposed to what I did earlier. On this one, if I multiply this by p minus 6, p minus 6, that's great. This has a common denominator of p minus 6, p plus 1, right? But when I came to this side, I have a 3 that I haven't accounted for. So basically, I just multiply the lowest common denominator times that 3, okay? And that 3 didn't matter. It could have been it could have been like p plus 5 or whatever. And then in that case, I would have to put like a p plus 5 here instead of a 3, okay? So let's look at this again. So again, here's my advice to you. Find the common denominator between two fractions first. And then if you want to put it like, I know that my common denominator, and don't write this down. Basically my common denominator for both of these, I could write it here if I want to. And then I have to then compare this denominator to that one. Like, what do I need here that I don't have here, and vice versa? Does that make sense? Now, again, not a great example for this one, because this one, what do I have here that I don't have here? Well, nothing. They're the same. Does that make sense? So if this would have been different, then you're basically comparing those two denominators and finding a way to find the common denominator here. Okay. And again, I don't think, I mean, I'm not doing the test, but I don't think you're going to have maybe 1 or 2 questions like this, and hopefully not that complicated. So this is my lowest common denominator. It's here. Okay. So anyway, so now this right here, all right, I'm going to multiply times each one here. Now, remember, this step is optional. You do not have to write this step. You might be able to do this step in your head, which is fine. So I'm going to get rid of that because you don't need it. I don't know why I put those together. But anyway, that's going to cancel with this. So I end up with 4b plus 3. Now this right here cancels with that. And now that's a -1. So -1 times 3 is -3.
-3.
And then now this is going to completely cancel with that. So you have v squared minus 3v minus 18. Okay. Now I'm going to go ahead and leave it there for you. All right. I'm not going to finish this one. Remember, at that point, you want to set it equal to 0. And I notice that these are going to cancel. That's 0. Does that make sense?
Yep.
Yeah, like terms. So then you would subtract the 4v. So we get a negative 7v minus 18. And then let me look at, yeah, I'm already looking at the answers and I can see how that's going to work out from here. So I'm going to leave it here. So all you have to do from here, if you happen to be watching this, or if you're Carter, just solve that. All right. But I know the hardest part for you, Carter, is finding the lowest common denominator. All right. So basically, remember, if you find, even if you find one that's slightly different, as long as the denominators cancel, then you're doing it right.
Got it.
All right. So let's go to 19. Sorry, I have to look at my computer to see what 19 is. Okay.
I was able to find the hole on this one, but I'm not sure where to go after that.
Okay. F of X. Okay. So really, a lot of the times, and it might be a misunderstanding, and I think I know what the misunderstanding is going to be, but essentially, you want to factor this, right? So that's going to cancel, right? So your whole, or the whole of this graph, is located at x plus 6 is equal to 0, which means that the x coordinate is going to be negative 6. And then, and let me write on here, and I know you guys don't have that much space, but essentially now I'm going to look at this equation. This is my new equation that I have to be looking at, and maybe that's the where you don't know what to do. All right, so this is my new equation right here, x plus 2. So I'm going to plug in that negative 6 into here.
Yep. Get a negative 3.
Right. Negative 6 over 2, which is negative 3. So the whole is going to be at negative 6, negative 3. All right, great. Okay. So that's good for that. Now let's take a look at what happens next, right? So I think, what is it, X-intercept normally? All right, so the X-intercept is when you set the numerator equal to 0. In this case, well, X is equal to 0. That makes sense. So this is going to be 0, comma 0. Let's see, vertical asymptote. Well, the vertical asymptote is when you set the denominator equal to 0, which is this bottom part, but 2 is just a number. It's not a variable, right? So that's never going to happen. So because that's never going to happen, then you don't have a vertical asymptote. All right, horizontal asymptote, and this is where people kind of sort of have trouble, right? We have to do bobo, botu, betsy. So I'm going to write it up here. And just to remind you that bobo means bigger on bottom, y is equal to 0. Botu means bigger on top, and y is undefined or none. There's not a horizontal asymptote. And then finally, you got Betsy, which is bottom equals top, and the C stands for the ratio of the coefficient. Of, I don't know, coefficient of numerator over the coefficient of the denominator. Anyway, so we don't really have one like that, but what's going to happen here, right? And that's the part that people kind of miss. Now, even though this is written like this, I could have rewritten this as 2 to the 0 power, 2x to the 0 power. Oh gosh, I already messed that up. Let me write it like over here. I could have rewritten like this, because we know that anything to the 0 power other than 0, any number other than 0 to the 0 power is 1, okay? So 2x to the 0 power is just 2. So therefore, this right here is going to be botu, which means it's undefined, which means you don't have a horizontal asymptote. And I think that's probably where you
Yep.
went wrong there. And then the domain is whatever it cannot be the vertical asymptote. I don't have to worry about that, but I do have to worry about the whole. So it cannot be equal to the x coordinate of the whole. In addition to the vertical asymptote, except for this one, I don't have one. And the range, it cannot be equal to the horizontal asymptote. It also cannot be equal to the y coordinate of the whole. So y cannot be equal to -3. And that's that. Does that make sense? I think probably that this being a 2 kind of messed everything up for you, I assume.
Yeah, I mean, I just had trouble trying to find the horizontal asymptote.
Yeah, I can see that. Most people, a lot of students in algebra 2 don't quite understand when there's a number. Like, what is it? What's the degree? Well, the degree, if you have only a number on the bottom, the degree is 0. Okay. Yeah. Let's go. Last question here, 21.
I have it almost factored out. So.
Oh, is the factor in the gotcha on that one?
No, I mean, I'm almost done with the factoring, but I was just not sure what to do after that.
Okay, 21. So you have f of x is equal to 3x plus 3 over 2x squared. So do you want me to do bottoms up on this one?
No, I can do it.
Okay. So look, on this one you can do bottoms up, and that's fine. I don't want to, a lot of you, that's the only system you know, right? Now this is a common factor of 3. Now on the bottom, if you're good with arithmetic, just numbers, right? If you're not good at it, then forget anything that I'm saying right now, all right? So it's gibberish. But the only factor of 2 is 2 and 1. So I know my factors are going to be this. So this one's the one that I would normally not do bottoms up, because in addition to that, I know that a +7 and a +9, that means that it's got to multiply to be, because you have a +7, you're going to have the same sign, and because they got to add up to a +9, they're both going to be positive. So at this point, all you need to know is what's the only factor of 7? 7 and 1, right? So either the 7 is going to be right here or the 7 is going to be right here, but they have to add up to 9, which is the middle. If I put it right here, for example, if I were to FOIL 2x times 7, that gives me 14. It's too much. That makes sense? But if I put a 7 and 1 here, that's going to work out. Right? So again, but do bottoms up. If you're not good at arithmetic, and you all know who you are, then don't do it like that, because you're just not good at those kind of stuff. So stop it. I'm trying to be politically correct since I'm on video here. But anyway, here's my whole. X plus 1, right? Whatever I cancel, I set that equal to 0. So I get x is equal to -1. Now notice that my new function now is going to be 3 over 2x plus 7. Like that, right? So that's my new function right there. So now f of -1 would be 3 over 2 times -1 plus 7. So it's going to be 3/5. Right, so the whole is going to be -1 3/5. Okay. Now, let's see. Then after that, really, and that might be the other thing that messed you up, like the X-intercept, for example. The X-intercept, you set the numerator equal to 0. Well, this cannot be equal to 0 ever. 3 will never be 0, so you don't have one. You don't have an X-intercept. Vertical asymptote, set the denominator equal to 0. So you have 2x plus 7 equal to 0. So x is going to be -7 over 2 or -3.5. Horizontal asymptote. All right, if we look at this one, same idea, but just backwards. All right, now this one's going to be bigger on bottom, because even though I don't have an x here, I could have written this as 3x to the 0 power. All right, so this has a degree of 0. This has a degree of 1, so it's bigger on bottom, which is Bobo, of course, which is y is equal to 0. Okay? And then finally, the domain would be x cannot be equal to the x coordinate of the hole, and x cannot be equal to the vertical asymptote. So x cannot be equal to 7/2 and -1. And the range, same thing, it cannot be equal to the horizontal asymptote, which is 0, and also it cannot be equal to the y coordinate of the hole. So cannot be equal, cannot be equal to 0 and 3/5. All right, so that's it. All right, do you have any other questions?
I think I can do the rest. So I only have one more problem. So
Okay.
I think I'm good.
Yeah, let me know if you need anything else beyond the, okay.